Hello there, this is Hans Forschner with Napcon Engineering Network. This video discusses the process of importing USGS topographical LiDAR data into the SoundPLAN version 8.2 software. This video is for educational purpose only. Please aware that some of the sections may change over time as online application, the USGS website, or software application SoundPLAN may change. So first I will go over the USGS website. You will see the link in the description below. As of May 2022, we'll find the site, the LiDAR data, and then download the LiDAR data. Then the second step will be how to import that into the SoundPLAN version 8.2 Geo-Database. So let's get started. So here we have the website. Please go to appsnationalmap.gov. So here we'll find the link below, and in here there is the national map TNM download client. So we click on the download client and it opens up this client, and at this point we want to make sure that we want to look at LiDAR data. So here on the left hand side, elevation source data, elevation sources, we select LiDAR point clouds, and ideally the LAS or LAZ file format. Then here on the right hand side we can define the address, and I will use Birmingham, Alabama, and I'll have a location right here that is of interest, maybe somewhere around here. And with this setup right now we can share or search the products. So here we selected what products we're looking for. So again, LiDAR cloud points, and then here the LAS, LAZ data, and then here we click on search products. So it goes through the data set and we'll go over that, and here we can see that it found multiple data sets. And as we go down the list, if we zoom out a little bit further, you can kind of see what it downloads. So if you need more information over a larger area, you can select all of them, or click on the download links for each of those and download the files. So in this case, the file that I'm interested in is, I think, let's see, let me zoom in again. It's actually this one here. All right, so I'll go here, and you can check the vendor metadata here. I'm not always too happy about the information. It's sometimes it has the information that you need. In some cases you don't. So in this case you can open that up, and it opens up, and here we can look for any clues in terms of EPSG code or any type of reference to any type of reference systems. So here I found a reference to North American 1983, GRS 1980. I'm not sure if that's quite right, so just keep it in mind, and we'll kind of keep that in our records. One of the things that I do know here is that right now the setting is in X and Y, longitude, latitude. We actually need the information in UTM, so please change it to UTM. And then we can download, click on the download link, and that will download the LiDAR data in terms of a LAZ file. So I'll click on that and it starts the download. So I jumped ahead and I copied from the download link the file that was downloaded, and I put that into my SoundPLAN project. I created a USGS LiDAR import project, and then just dumped in this LAZ file into the project file or project folder. And at this point we go ahead and so at this point we go ahead and we continue with the SoundPLAN software or software model. So this is the USGS, let me correct that, USGS Lidar import project. And here in the settings I already have the coordinate system and reference system set up. This is if you open up the Lidar file, the LAZ file, you will find, so what you can do with the laser file data, you can open it up in a notepad or just with edit, and this will open up the file. And what we want to look for is any type of references to coordinate systems. So after you open up the LAZ file in the editor, you can look at the very top. This is of course a compressed file, so it's not an ASCII file, but every now and then you can see ASCII elements here. So here we have net 1983 state plane Alabama West. So this is an indication. There's another indication, North America 1983, the date stamp, GRS 1980. I would suggest to just do a screenshot of that information, and so you have that, you don't have to reopen it. And so command and then make a screenshot. One of the things that I noticed from this information is the information that is saved is in feet. So after we do the import into SoundPLAN, we need to convert the X, the Y, and Z into meters. So that's just something that we need to do. Other note, in some LAZ files, there are references to EPSG codes. I've seen LiDAR data with 3 or 4 different references of EPSG codes, which is a combination of reference system and coordinate system. SoundPLAN may not support all of them. In that case, you just have to troubleshoot and try different EPSG codes, and then SoundPLAN will tell you if one of them will work, if it finds it in the database. So let me close this at this point, and we can minimize that. And then again here, in terms of the project description, here I have a NAT 83, US and Canada, WGS 84 selected. And then I also have selected in US state plane from 1983 for Alabama West. So that should be all good. Maybe I'll turn on the strip to 0 for the time being, and I'll click on the check mark. If you don't see the right coordinate and reference system, you may want to check in the program settings under global, under selection of coordinate systems. Here you can check or uncheck which coordinate systems are showing. So there is, I don't know, maybe 600-800 different coordinate systems or state planes under the coordinate system, and then also under reference systems. So you make sure that the planes or the countries that you're working in are selected, and then they will show up in this project description selection under the coordinate system. Here's also the selection of EPS code. So in this case, you just type in the code, and you will check the program if that EPS code is available. Then it will show you what coordinate system, reference system, in some cases any offsets that you may have, and then it will confirm that that EPS code is supported. Again, some of these LiDAR data files have several coordinate EPSG codes referred. So you just have to make a screenshot and then try which one are supported. So now at this point we are ready to go to the Geo-Database and import the LiDAR data. So here I open up the Geo-Database, and the LiDAR import you find under File, Import, and Processing Elevation Points. So this here allows you to do processing of elevation points that are multiple LiDAR settings. So if you have a city, you could have 100 of these files. And in that case, you basically do a pre-processing, and that's like what I'll do, even if it's just one file. And at this point, we select the files. So here is the LiDAR file. Here we can select by different formats. So in this case, it's laser scan LiDAR data, and I'll open that up. And the first step is it just opens up the file. The second step will be that we get the detailed information from the file. And then after that, so here get the file information, and we execute that. So now it searches through the file. So at this point the file is in memory. So here we see now there is somewhere around 2.8 million points in the in this scan on this LiDAR data. And here we can define what type of filtering we want to define. So here, for example, the maximum point distance is 80 meters. Maximum height difference is 1. I just want to refer that the program thinks this feet data is in meters, so it's actually feet. So we could, so these inputs actually will mean we the maximum space difference we can increase it to 200, and then here maybe to 2 meters, which actually means it's still within 0.6 meters. Let's make it 1.5, and then 200. So it's much more detailed than that we think it is. And at this point I'll execute, and the program loads all the points, and at this point it goes through this filtering and will reduce the number of points, and it starts with the minimal points, and then as the second criteria of the height difference between reduced DGM and the original is improving, it adds more and more points. So at this point we can save the results in a subfolder called LF data. So again, if you have more than just one file, there you could have, I don't know, 20, 30 files that will be all saved in there. And then you can kind of post-process that further on. Another option is save them as a geo-file. So this is what I'll select, and so I'll select spot elevation, laser 000 spot reduced. All right. And I execute. So if you, yep, that was it. And here on the bottom left, or bottom right, you can see how many remaining points we have. So 57,000. So 98% of the points of the point cloud was reduced. So from 2.8 million down to 57,000. So that's pretty good. So let's exit out of this here. And we can turn on the so let me open up the geo-file. So load and create geo-file. I'll open up that reduced data set. And here we have the data set. Now here we can already see if we can, this is like a 4-lane freeway, and so this is over, let me just double check. From here to here. It's over 200 meters, so this is definitely an indication that this everything is in feet. So let me delete that again. Let me go back. We select all, and at this point I'll convert the coordinate in coordinate operation, and I multiply the x times 0.3048. I convert the y times 0.3048, and the z times 0.3048. Execute. All right. You can double check again. Approximate width of this roads. So here now it's about 50 meters. Yeah, that's in the ballpark. All right. And so let's go back out. We can save the data. Base model with Lidar data. And we can zoom out. And at this point, we can go fundamentals, and if everything is correct with the reference system and so on, we can connect to OSM and Google Maps, and we are right where we should be. So here is again the freeway settings. We can import the viewport, aerial, and it fits right over it. Okay, and so here if we wanted additional information for this area, then of course we import the next Lidar file. Let me go back to the online map and maybe look at what OpenStreetMap data is available. So I go download, import OpenStreetMap. Again, this requires the Cartography and the GIS module. I'll import buildings and roads. Note that in terms of buildings, they have no elevation, and in terms of the roads, yeah, they don't have any traffic data. So road and the road data is really only for display purposes, and the buildings, just make sure that they are layouts. They may not necessarily have the correct elevation or height. So after you develop your ground model, so let me just do that here very quick. So fundamentals, DGM, calculate DGM. So calculate the digital ground model. So DGM, and this will be all based on just the Geo-file that's based on the Lazer data. Okay, and so here we can take a look at the 3D map. So here we have the 3D map. Looks pretty detailed, and you can see that the roads and the buildings are of course way below because they don't have any elevation information. And now at this point we can select all the buildings. We can view current object type, select the buildings, and drop the buildings onto the ground. And let's see how that looks now in the 3D map. Yep, so some of the buildings are now on the terrain. So that makes sense. And of course the rest is outside the ground model and has no elevation. All right. I hope this was helpful in terms of the modeling or the importing of the LiDAR information. Make sure to double check in terms of the coordinate and reference systems. Also make sure to notice like any type of bridges. Like here we have a bridge going over the freeway. Of course that needs to be addressed in terms of the input of the road and all the traffic information and so on. Thank you for listening. If you have any questions, please feel free to comment on the video or send me an email. Thank you and have a great weekend. Thank you and bye.